In this section, I'm going to demonstrate the interaction between our two key products, ICS Manager and HTZ Communication. And we're going to take broadcasting coordination as a use case. Also, I'm going to be touching on the ability of ICS Manager user to design views and collate information in real time, and also to do some basic statistics. So the idea is these two products together, providing a turnkey solution, allowing you to exchange all the technical parameters required for coordination procedures. So ICS Manager on the right is giving you a snapshot into the real time or the real snapshot, up-to-date snapshot of the database, Spectrum database. And the tool on the left-hand side is the planning tool that does all the coordinations and coverage predictions analysis. Now, these two tools have an API and they can communicate seamlessly. And the information you can communicate is like devices, the laps, the channel plans, the RPE antennas, coverage calculations as well, and so on. Now let's run HTZ. Now let's run HTZ Communication first. Now let's run ICS Manager from HTZ. Let's open the workspace. So this is ICS Manager is ready now. So logically you would go under devices if you want to import a broadcasting transmitter. But you see this is right now showing all the information for the entire database. Now, if you wish, you could filter very quickly. You can go and filter here and specify the license type, say broadcasting. You can also do filtering by subtype by going to the second level of filter, and then you can specify here whether it's in a national broadcasting or commercial radio and so on. Now, you can create multiple versions of this table. Basically, everything here is customizable. So you can see here I've got some filters applied to broadcasting license type and license category, and I can see here the lab attached in some cases. I can see the state, or if you go to the query here, you can design the view. So say you decided to add coordinates to that table. So this is the device table. You want to get the coordinates. Very easy. You just need to go to position first. So you need to find the right table. This is the table, position table. And then you can see here you've got the longitude, latitude, and the datum. Okay, so all you have to do is literally just drag and drop it. You just put them here in the end, for example, and then save and close. Now you managed to update your view, go all the way to the end. Here we go. We've got longitude and latitude. Now let me show you some basic analysis you could do on that table. So for example, if you want to see the distribution of base stations on a site or devices on a site, or if you wish to see the frequency usage, you could just simply click on the frequency and then go to statistics. So very quick. So we've got here the frequency and how often it's used in Australia. So now I just redesigned the view for this filter here. Now you can see here I've got filter broadcasting. So you could change the filter if you want. Show and map. Select all of them, and here we go. So you can see where are they actually on the map, and of course you could run different filters on frequency and so on. So here we also have a dedicated table called the laps here. This is all the list of license areas in Australia. You could actually import them directly from a shape format. In the tool there's an option to import it directly. So I already did this importation here, and you can see each one of these is a lap, and that lap has certain polygons information attached to it. Now what I could do here, I could actually search as well. So I can go here, filter like Sydney. Here we go. This is Sydney TV lap. Export to HTZ directly. So you can go export completed. So you can see it here. That license area is now imported into the software. But first I need to export some stations from ICS Manager. So this is my table for the devices for broadcasting stations in that case. I'm going to apply a filter by state. DXA. Here we go. So I've got two sites now here. I can click on the site And then I can see here the different information. I can see the owner, the network license, and I can see the frequency attached to it, channel plan, and if it is compliant with the channel plan or not. And I can see the position, and I can also see the coverage, if the coverage has been pre-computed. And obviously it is in that case here. And you can see there's a palette. Now this is a great benefit because you can see the coverage while using ICS Manager. So as a Spectrum officer, if you wish to see the coverage without using the complication of planning tools, you can just do it here. And you can change the palette as well. So now let's export this to our tool. So you see this is a soft link between these two tools. Now we go back to HTZ. Here we go, that's my station. The database is already also has a snapshot of the coverage. HTZ communication is a very comprehensive tool. We have everything you can imagine when it comes to propagation models. We have ITU 5 to 6, so we have ITU 1546, 1812, 452, 368, so VHF, UHF, ground waves, sky waves, even aeronautical. We also have the ITM models, and for the Australian market, we have the modified HATA for spectrum coordination procedures. Tool is, as you probably already know, it has a digital terrain model. So we have the map for the entire country and for other countries as well. And we have it in 20 meter, 30 meter resolution and sometimes higher. So the tool allows you to switch between terrain and the clutter and satellite imageries from different sources. So let me quickly show you coverage prediction, how it works. You put the receiver height, the range, and you run the coverage. Now you can run some analysis here. For example, you could do filtering, vector polygon filtering, and you can check the coverage percentage based on that polygon. So we have 68% of the coverage in that license area. The tool is importing all the information about the site. So all the technical parameters came in, including the frequency plan. And you can see the tool is capturing all the list of channel plans. And these actually came from ICS Manager. The antenna pattern will also come from the database. These two tools, they also have, they can exchange RPE antennas. Do the culling and import all the list of sites that can potentially be victims or potentially can cause interference to this space station. Or 250 kilometers, and then say you want to do it up to 20 meg plus or minus. So here I'm going to use the terrestrial stations. This is what I have, all the list of devices in the database. Search. Okay, found the 30 records. That's all the list of stations that can potentially be problematic. Export to HTZ on the map directly. Here we go. Now again, if the coverage is already pre-computed, Control C should display the coverage. Now we go and run the population report. So I'm going to use the census data in the raster file format, and I could limit it to the vector if I want to as well. So here you define your minimum field strength. So you see I'm using Australian population grid 2016 in ATDI format. We downloaded it from the government source. Sometimes the license area is made of multiple polygons, so the tool is going to give you a report per polygon, and you can see here the percentage of population covered and the actual population covered. You see the tool automatically updated the population information as well. So you're looking at 4.7 million. Now you don't have to do it based on the lap, you could actually do it for the entire area. So same technique, 55 dBu minimum value here, and then hit OK. So here you go, we've got the total population. So we have roughly 4.9 million covered by that transmitter. So we could run interference analysis now. If we use the shortcut Q, for example, it will show you the core channels, how they are distributed. So you can see this site and this site here in North Sydney, they actually both have the same frequency. But obviously this is a small transmitter, and this is a massive transmitter, and there's probably enough separation between the two. So you could conduct interference analysis to see what is happening here. So you simply have to go to coverage, network interference, C2I mode. We've got a number of modes depending what you're doing. This is dedicated for broadcasting. We could use global interference, which is checking interference both ways, A to B and B to A. and you could define the technique you want to use, the C2I values you want to use. You can rely on our database, or you could define your own mask. Hit OK and run the calculations. If there is any interference between these two sites, it should show up. Here we go. And you can see here, in each case, we are treating different station as a victim. So wanted or victim, TXA. So this is the North Sydney one, and then Win Television, probably some community television here. So you can see each one of them is impacted very, very little, and a little bit more impact on the Win Television site. And now the tool should visualize where the interference is. Here we go. Very clearly, we can see there's some interference. I might show you quickly how you could how you can run the analysis and find out what's happening there. And then you right click, you can see the dominant server in that area is actually this is probably this site here, and you can see who is the interferer. So the interferer is a co-channel, COV, so co-channel vertical in that case, and frequency 226.5, which is a co-channel, and I can see the C2I is actually only 0 when I'm expecting a 20 dB protection. So this is 86. Sorry, 86 is Sydney site. So it's site 86. So this is obviously a very high transmitter, very high power transmitter, and it's serving even the area here. So if you wish to check how many people are victims or in area of interference, you can easily just go run the report. You could do it side by side if you want to batch the process or whatever. Let's see how many people are impacted. So only 171 people are actually impacted or are in locations where we have interference between these two transmitters. Now let's see, I'm going to run just a dummy frequency assignment to show you the process. So basically we want to assign only that guy here. So go to isolate. So here we go, this one active, everyone's deactivated. I wish to do frequency assignment. But before I do that, I want to remind you that we have a digital TV frequency plan attached to that base station, which is awesome. To do interference analysis or frequency assignment, you do need to have coverage, because this is a full deterministic process. We've got so many options for you, and the easiest at this stage is to go with a channel plan. So transmission plan assignment. So we already have a plan, so why not? You can assign TX, TX, RX, and so on. I'm gonna do only TX. So that's it. We've got the bucket here ready. Now we can go with sequential assignment. Sequential assignment means always prioritize lower frequencies or lower channels. Okay. Monte Carlo is more random, so it's going to be a random process. So if you wish to reuse the lower part of the spectrum, I would go with sequential. And you can put some conditions for multiple frequency assignments. For example, if you are assigning a main transmitter and a repeater or a gap filler, then you could actually assign the same frequency for them without causing self-interference. So now we could give the tool a chance of 10 times to try and find a solution, or we can go higher. I'm going to use interference approach to sort this problem. I'm going to use C2I protection ratios that I defined previously, and that's it. So now you just go hit start, and then you let the tool run the calculations. So the tool found a solution, obviously, and well, this is not ideal setup I'm showing you. So you're supposed to import all the incumbents and put them on the map, so you could do frequency assignment in the presence of incumbents. So we got a frequency, it looks like. Okay, I'm pretty sure it's not going to be the best frequency, but we've got something. So let me show it to you. So this is the frequency that was chosen. It's 210. And this is the dimensional plan that I have attached to this. So now if you wish to send this back to your database to carry out the coordination process and reassign a job to Spectrum Officer to issue a license, so as a frequency assigner, your job is pretty much done. You just need to go File and now Save. And save, I'm going to save it straight into the database, into ICS Manager. And that's really the beauty of this solution. So we go and send it. So you see now ICS Manager is flashing yellow, so go there. There's something incoming. Save stations, yes please, continue. Apply the changes to the tool. Notice there's a change in the frequency, change in maybe coverage, or whatever technical parameter you change, including antenna. It will pick up the change, and then you can go and apply it. So now you managed to update. This is the log. You managed to update the record successfully. I'm talking about this one. So this transmitter, which is a TXA, now if you go to the position, obviously you can use satellite images here, and you can see the coverage. So the coverage I already showed it to you, but this coverage actually is based on the latest coverage you predicted in HTZ just now. So, all right, so you can put the user palette and then analyze it in the process.